Okay. So while you guys are doing these two warm-up problems, I will be talking in the background about the rest of the semester. So today is Thursday. After today, you will be able to do all of worksheet 17. Worksheet 17 is due by Sunday night. Turned in on It's Learning. Starting at 2 o'clock this afternoon, and the only reason I do it at 2 o'clock this afternoon is so the afternoon class and you have the exact same amount of time to do it. So starting at 2 o'clock this afternoon, there will be a brief formative assessment. I believe it is 5 total questions. It should take you less than 15 minutes to do the formative assessment this afternoon. That is also needs to be done before Sunday. Okay. Then next week, Monday, we'll be talking about some word problems. And then Monday afternoon, your Unit 5 summative will open up. That one is a 10 question. It's more of a quiz. I don't really want to call it a summative. I don't want to call it a test. It's more of a quiz. That one I am asking to be done by Wednesday afternoon. So Wednesday at 3 is what I have that one for. Because it shouldn't take you very long to do that one either. Then next week, Tuesday, I will be available for final review questions. You all have the final review packet, the sheets available for that one. That final review packet is due by Friday the 15th at 3 p.m. And you also have the semester 1 final, which is 12 questions long, and it is also due by Friday, January 15th at 3 p.m. I will open it Wednesday morning. So you'll have Wednesday, Thursday, and Friday. Okay? So are we going to have to start? I missed the question and then it popped away. Are we going to have to start asking to use the bathroom instead of just taking the Chromebook with? No, because your camera will be on, Archie, and you can just leave the Chromebook there and then you can go to the bathroom and then you can come back and your camera will still be on. Okay? Okay? Anybody need more time on these two equations, these two warm-ups? Okay. From yesterday, we had 4 steps. First step was isolate. Second step was switch. Third step was solve. And the last step was check. So the exponented term is isolated here in letter A. So we can switch forms with it. Log base 2 of 15 equals x minus 8. We can add 8 to both sides then. The exact answer here would be 8 plus log base 2 of 15. And then we could utilize our calculators. And we could say that 8 plus log base 2 of 15 is 11.9069. 11.9069, which we round then to 3 decimal places. So I would say that this, come on now, I would say that this is 11.907 is my x. 11.9 minus 8 is like 3.9. Okay? 3.907. 2 to the 3.907 power is going to be very close to 15 because 2 to the 4th is 16. So that checks out for me. Yes, ma'am. You can have no solution, yes. And you can have solutions that where like you might get 2 answers and one of them goes away. Yeah. Letter B, the log is isolated already, so we can switch forms with it. 3 squared equals x minus 6. 3 squared is 9. Add 6 to both sides, and we get 15 is x. When I put 15 back into the equation, 15 minus 6 is 9. Log base 3 of 9, what exponent do I have to put onto 3 to get 9? That's 2. 2 is equal to 2. It checks out. Good? Okay. So, one last form of logarithmic equations, and this form is going to require us to know our properties, or remember, I should say, our logarithmic properties. So I'm going to give you here a couple of minutes to rewrite them down, and then I will explain them for you. Okay? So take this time to write them down. So the properties of logs, and I will briefly go over these now because you should have spent some quality time with them back in Algebra 2. The properties state that if you have logs of the same base that you are adding together, you can take those individual arguments and you can combine them using multiplication. Okay? So it takes 2 logs and it combines them into 1. Okay? Very helpful. Okay? So when you have 3 logs, or if you have 2 logs and a number, that's going to be the kind that we majority of the time have is 2 logs and a number. You can combine them into 1 log that isolates the log, then we can change forms and go through solve it. Okay? So addition goes with multiplication. Subtraction goes with division. So if we are subtracting the logs, we take the top divided by the bottom, or the first divided by the second. It would be a better way of saying that in that specific order. Okay? Power property, we're not necessarily going to need that much, but that's the third one. And that just says that if you have an exponent inside the log, you can put that exponent out in front. Or if you have a number, a coefficient out front, you can put that in as an exponent. Okay? But we're not necessarily going to need that. We're really going to look more product and quotient properties as we go through here today. Okay? So let's try one of these. So we have log base 2 of x plus log base 2 of the quantity x plus 1 equals 1. Now I can't ever isolate the 1 log because there's 2 of them. And I can't get it log equals log because there's that 1 sitting out there on the other side. So what I have to do is I have to combine these 2 logs using one of the properties. And since I am adding those two logs together, I'm going to use the product property. Adding goes with multiplication. So this would become log base 2 of x times x plus 1 equals 1. I combine them by multiplication. And now I've got a single solitary log. That's a good thing. I've got that single solitary log isolated. That's a great thing. So now what I can do is I can switch forms with it. I've done step number 1. I've isolated my log. I can switch forms with it to 2 to the first power equals x times x plus 1. And now I can solve that. 2 to the first power is 2. X times the quantity x plus 1 is x squared plus x. Because I have a squared term, I've got to get everything onto one side. So I'm going to subtract 2. That gives me 0 equals x squared plus x minus 2. And then I can factor. Two numbers that multiply together to be negative 2 and add to be positive 1 are positive 2 and negative 1. Then I set each of those factors equal to 0. We've done this a couple of 3, 4, 13, 18 times this year. And I get x equals negative 2 and x equals 1. Okay? So now I've done step 3, solved it. Step 4 says I need to, actually here, let me rewrite it down here at the bottom. We'll do that instead. It was log base 2 of x plus log base 2 of x plus 1 equals 1. I need to check my work now. So I'm going to put negative 2 into my equation, and I get log base 2 of negative 2 plus log base 2 of negative 2 plus 1 is negative 1, and that equals 1. Okay. The problem is that log base 2 of negative 2 does not exist. Because from Monday, the base of our log has to be positive, which is true in this case. 2 is positive and not equal to 1. But the argument, what's inside the parentheses here, that also has to be positive. And that fails actually in both of these cases. It doesn't exist there, and it doesn't exist there. So this negative 2 gets thrown out. I still have to check 1. So that would be log base 2 of 1 plus log base 2 of 1 plus 1 is 2. Log base 2 of 1, what exponent do I put on 2 to get me 1? That's 0. Log base 2 of 2, What exponent do I put on 2 to get 2? That's 1. Gets me that. 0 plus 1 is 1. 1 checks out. So the only answer that we get here is x equals 1. Now, if you notice, we picked out the negative answer. That is not always the case. Most of the time, yes, it is the case. But you have to go through the steps of checking it in order to make sure that that is the one, the extraneous solution, the answer that gets thrown. Okay? Questions on that? In here or out there? Okay? So what I would like you to do now is I would like you to try this particular problem. Okay? So 2 logs, same base, adding, I can combine them into log base 3 of x minus 9 times x minus 3. That still is going to equal 2. Again, so I've isolated my log. Now I've got to switch my log form. So then this would become 3 squared equals x minus 9 times x minus 3. 3 squared is 9. X minus 9 times x minus 3 is x squared minus 12x plus 27. Subtracting 9 from both sides gives me 0 equals x squared minus 12, excuse me, minus 12x plus 18. 2 numbers that multiply together to be 18 and add to be negative 12. I don't know of any. Okay? So that means we have to go to our old friend, the quadratic formula. So the opposite of negative 12 would be positive 12. Negative 12 squared is 144. 4 times 1 times 18 is 72. 2 times 1 is 2. So this is 12 plus minus the square root of 144 minus 72 all over 2, which is 12, plus minus the square root of 72 all over 2. Now, if I wanted to simplify that, I could. Okay? We could simplify that down if we wanted to. But really, we're looking for a decimal approximation, correct? So in one sense, I am going to do 12 plus the square root of 72 divided by 2. And that's going to equal, get out a calculator, 12 plus the square root of 72, and that's divided by 2, is going to be approximately 10.2426. Okay? And then we have to do 12 minus the square root of 72 all over 2. And that is going to be approximately 1.7574. Agree? Okay. Really, they would be 6 plus minus 3 square roots of 2 is what it is. Same thing. Okay, but again, we're looking at decimal approximation. Going back to my original problem, this was log base 3 of x minus 9 plus log base 3 of x minus 3. Well, if I plug in this first number, into x here and x there, I still get positive numbers, correct? Yes? So provided my math is right, I'm good. And we're good there. If I plug the purple box into the same spot, if I plug it in there, what happens? It'd be negative, and that can't work out, right? Or that doesn't work out. So this one, even though it's positive, gets thrown out. So the only answer that we have left here is x equals 10.242. Okay. Oh, sorry. Yep, 243. I didn't look too far. Is that better for you? Okay. So with that being said, I'm going to give you a mod to finish the worksheet that is due for this week. So there's no, I want to give you as much work time as I can these next couple of days because I know I'm throwing a lot at you here in the next 5 school days. So I'll give you time to do that worksheet. If you're done with that worksheet already, you can always start studying for the final by doing that. At Homer's, everything is posted on It's Learning. If you need to look at the worksheet and to turn it in. Okay? Thanks for playing along.